So this will be 3x1 plus x2 plus a1 is equal to 3. This is 4x1 plus 3x2 minus x3 plus a2 is equal to 6, and then this is x1 plus 2x2 plus x4 is equal to 4. This will become maximization of z is equal to minus 2x1 minus x2, then plus 0x3 plus 0x4 minus ma1 minus ma2, right? uh, Even if you do this much, you will get at least 1 marks. If it is totally 10 marks, maybe sometimes if more number of this one is, it may allocate it for 2 marks. So you have a chance, like if it is completely wrong, it's not necessary that you will lose completely. I mean, you will get 0 marks. It depends how much correct you have done, right? So same way, start with, I'm just starting, but I'm not going to solve this. It's all you people has to solve. x1, x2, x3, x4. Keep little distance between x, because m will be involved. a1, a2. Right? So always go with the first equation. You have a1. So write a1. And for first equations only, write down the coordinates. 3, here 1, here 0, here 0, here 1, here 0. This is 3. From the second, we have x3 and a2, but x3 will not take because it's a surplus variable. It has a negative coefficient, -1, which will lead to the infeasible solution. So we'll take a2. And we have 4, we have 3, we have -1, 0, 0, 1. And from the third equation, we'll be taking x4. So we are taking x4, then 1, 2, 3, 1, 0, 0. So this is our identity matrix, which it is giving in the term those variables are appearing, right? So here RHS are 6 and 4. Calculate ZJ. In some books directly they are calculating CJ minus ZJ. They don't calculate separately ZJ. If you are comfortable, if you are confident to do directly with CJ minus ZJ, you can do it. I will avoid because we may do some silly mistakes. That's why I will avoid to do directly CJ minus ZJ. But it all depends on your maths capability. Okay, will be dash CJ minus ZJ. This will be -2 minus 7am. So we'll write it as 7am minus 2. This will be 4m minus 1. This will be 0 minus m. This is 0. This is 0. This is 0. You can see that you will get 0, 0, 0 for the variables x4, a1 and a2, which are there in the basis matrix, right? Then definitely the m coefficient for this is 7, for this is 4. So this will be bigger one. So this x1 is moving, and here we will check 3 by 3, 1, 6 by 4, it is 1.5, and this is 4 by 1, it is 4. So this is 1 by 5, this is 1 and this is 4. So this is smaller, this will be leaving. So in the next iteration, we will be having, instead of A1, we'll be having X1. So let us go for red color. So next iteration we have X1, we have A2 and we have X4. Right? The pivot element is 3. So first calculate X1, 3 by 3, 1, 1 by 3, 0 by 3, 0 by 3, 1 by 3, 0 by 3, 3 by 3, 1. The coefficients of this are minus 2, minus m and 0. Right, so we got this. Then going for A2, in A2 we want x1 A2 0, A1 x4 A2 is 0 and A2 A2 1. So we want these values to come over here. So checking with this, taking old A2, 4 is here, 1 is here. So that means if you multiply this 1 by 4 and then you subtract from this 4, you will get, right? So multiply this equation by 4. Multiply by 4 and then you subtract it from the old A2. So you will get 0 here. Here also it will be 0 into 4. So 0 minus 0. Here also same. So just go for the next one. This is multiply this by 4. So 4 by 3. And subtract from 3. So 3 minus 3 by 4. Sorry, 3 minus 4 by 3. So it will be all 9 minus 4 by 3, which is 5 by 3. So this will be 5 by 3. So multiply this 0 by 4. So it will be 0. Subtract from minus 1. So this is minus 1 only. Multiply this 1 by 3 by 4. So it is 4 by 3. Subtract from this 0. So it will be minus 4 by 3. Same thing, multiply this 1 by 4 and subtract from this 6. So it will be 2. Then going to the next one. The second iteration in red. So in second iteration you can see that A2 is going. That means both the artificial variables are gone. I think by third iteration you are getting the answers. Right?